Hello, welcome to my YouTube. Okay, so today we are in math session. We are going to look at approximation, questions on approximation. We have questions like upper limit, lower limit, tolerance, relative error, and also percentage error. So that's our today's work. The question reads, a container of cooking oil has a mass of 15.4 kg. Find the tolerance of the mass of cooking oil. B. Write down the relative error of mass of the container of cooking oil as a fraction in its simplest form. That's question 1. So this question 1, when you answer question 1A correctly, then you get what? 2 marks. Then again the second one, 2 marks. So in short, you have this question in paper 1 and you get what? 4 marks. Then the second question reads, the length of a sugar cane is measured as 2.6 meters if its true length is 2.5 meters. Find the absolute error, then B, percentage error. Then the last one, a bag of potatoes has mass 15.4 plus or minus 0.05 kg. Find the tolerance of this mass. Then B, write down the relative error of the mass as a what? As a fraction in its simplest form. What you are seeing here, when you just understand the 3 questions here, meaning you are okay, you can easily get what? You can easily score 4 marks in paper 1 just on this topic. We'll answer the first one here. The first one is saying, find the tolerance. So tolerance is the measurement, or we can say it's an error which you are supposed to do what? Tolerate. For instance, if you get that 25 kg bag of meal, you try to measure it using your own scale. It's obvious you won't find 25 kg exactly, but it will be slightly below or higher. Now, if you measure and you find that it's not the actual 25 kg, you can't even sue the company because there is a tolerance. They'll just easily calculate tolerance for you, and again, you can't even sue them because there is a tolerance for any measurement. That tolerance meaning it's something which you are supposed to do what? Allow. That's to tolerate. You just allow, meaning you can't even sue a certain company for giving you something which is less what is labeled there or what is more. So that's what we calculate here, tolerance. Understand that for you to find tolerance, you say tolerance is equals to, you find upper limit minus lower limit. So this is the formula for what? Tolerance. Now, you need upper limit here. Again, you need what? Lower limit. You subtract, then done. So we'll find now upper limit here. To find upper limit, you get the true measure plus absolute error. The true measure here, meaning it's the actual one. Then absolute error you will find. Then now, true measure in this question, true measure is what? 15.4 kg. So where there is TM here, you put 15.4 plus absolute error for this. Then it's this part now which is a bit tricky. So long as you are able to know how to find absolute error, then you are okay. To find absolute error for this question, check, we only have one measurement or one number here. So if you have one number and you want to find what? Absolute error. Here we encourage you just to master. We have 15.4. We want to find what? Absolute error. So I will also show you how to find what? Absolute error in case they swap the question. So absolute error for this question here, for this number, it's 0.05. That's the absolute error. So any number which has one decimal place, one number after a point. One number after a point, absolute error is what? 0.05. Then for the whole number meaning a number without a decimal place. For instance, if we add 15 here, then the absolute error becomes 0.5. Then if you have a number with two decimal places, meaning two numbers after a point, for instance 15.41, then the absolute error becomes 0.005. Just understand this, then you are okay. Whole number, absolute error 0.5. Then a number with one decimal place, absolute error 0.05. Then with two decimal places, 0.005. Three decimal places, it will be 0.005. So that's the information which you have to understand to find absolute error. If you're able to get this, then everything there will be simple. You just score 4 marks for free. Okay, so in this case, our question here, it has one decimal place. Absolute error becomes what? 0.05. Then here now you just add. To add here, know that if you're adding this kind, you say 15.4, the point will come here. Then after a point, we have 0, 5. Then we have 0 here. Add. Here there is nothing, meaning it's the same as this what? 0. 0 plus 5, 5. 4 plus 0, 4. Then point will come down here. 5 plus 0, 5. 1 plus 0, 1. So that's the what? Upper limit. Upper limit you add. Upper limit you add. Don't forget. So we have upper limit as 15.45. That's the upper limit. Next now we need what? Lower limit. Lower limit. To find lower limit, you get the true measure minus absolute error. So true measure is the same true measure there, which is 15.4 minus absolute error. Absolute error is still the same absolute error, 0.05. You subtract. You won't have a calculator, mind you. So meaning you have to understand, or you have to know how to subtract numbers with a point, and how to add numbers with a point, and how to divide numbers with a point. So what you do here, if you want to subtract, you get 15.4. Then now the point will come here, 0, 5. Then 0 will come here. Then here there is nothing, meaning there is 0. We are subtracting. You start from this side. 0 minus 5, it can't. Get 1 here, you remain with 3. 1 will come here, 10. 10 minus 5, 5. 3 minus 0, 3. Point will come down here. 5 minus 0, 5. 1 minus 0, 1. So you have 15.35. That's your what? Lower limit. So here we have 15.35 lower limit. The final answer, we want to find the tolerance. Tolerance. We said tolerance, you say tolerance is equals to upper limit minus lower limit. So upper limit, you get upper limit, which is this one, 15.4, minus lower limit, 15.35. Subtract. To subtract again without a calculator, just do this. Very simple. There's nothing here, you put 0. The 1 will come here because it can't there, so meaning here you remain with 3. 10 minus 5, 5. 3 minus 3, 0. Point down. 15 minus 15, 0. So tolerance is 0.05. So meaning in short, in this container of cooking oil, they were able to tolerate 0.05 kg. If there's just a difference of this, or 0.005 or 0.05, then you have to tolerate, because that's the tolerance. So done here. Before we move to B, the same tolerance or the same upper limit and lower limit, at times the question can come like this. They'll just say mass here less than or equal to dash, then here again this dash. when the question comes saying complete the statement, meaning that statement here you have to find the lower limit. The same way we are finding lower limit, you write it here. Upper limit, you write it here. So if you say a question, when you're going through paper 1, if you just see a question where they're saying complete a statement, meaning in short they're saying here write what? Lower limit, here upper limit. Done. Okay, so we are done with A. It's simple, it's just that I was showing you step by step, but it's simple. You can just easily get 2 marks here. So these are the questions that I would encourage you, especially that you are about to write the final exam, especially to the GCE. These are the questions that you have to be practicing so that you get 4 marks. Okay, B, write down the relative error of the mass. Relative error. So understand the formula for relative error. So you say relative error is equals to absolute error over true measure. That's the formula for relative error. So absolute error, to understand absolute error is the same. Again, I will say it. If you have one number, just master that for the whole number, then the absolute error becomes 0.5. Then a number with 1 decimal place, the absolute error is 0.05. Excuse me. Again, when you have 2 decimal places, you have 0.005. Just understand that, then you are okay. For one number. Okay, so absolute error, here we have one number, but now there is 1 decimal place, so you get 0.05. Over true measure, we have 15.4. If the question was open, you just end here. Now the question is a condition here. They are saying in its simplest form. Simplest form meaning you write it now to the point so that you won't have any number to go into a numerator and a denominator. So what you do here, you just remove a point because you can't divide. You can't look for a number. It will be stressful. So you will do what? You remove points. To remove a point, you remove a point here and here. Now the one which you follow is the one with more decimal places. So here we have 2 decimal places. Here we have 1. So you consider the one with the more decimal places. So meaning you multiply times the 100. Because 100 it has 2 zeros. The zeros are the ones which will push the point on your right 2 times so that you move a point. 1, 2, then you have 5. Now whatever you do on top, do it also down. Multiply 0.05 times 100, you have 5, meaning the point has moved 1, 2, so you have 5.0, same as 5. Then here now you have 15.4 times 100, meaning the point will move to your right 2 times. Point up, so meaning you say 1, 2. Next now, look for a number to go into this and this. So here you say 5 into 5, 1. 5 into 15, 3. So when you are dividing the first number, don't say 5 into 1, no. You get 2 numbers. So 5 into 15, 3. Next now you say 5 into 4, don't say 40. Now it will be 1 number. So 5 into 40, it can't. If it can't go there when you are dividing, you write 0. The same 4 now will be here. It will now be what? 40. Then 5 into 40. 8. So meaning your answer is 1/308. If you are not careful, you write 38, which is wrong, especially if you're not understanding this part. Okay, so here you are done. So that's how you find relative error. Understand the formula, absolute error over true measure. The only trick part is absolute error. Make sure that you go back again on that part where I was explaining on what absolute error, because the formula, it's easy. Okay, so done with question 1. Next question. The length of a sugar cane is measured as 2.6. If its true length is 2.5 meters, find the absolute error. Same topic, same question. But now there is just a minor difference. Here we had one number. Now check on this question, we have two numbers. We have the one which was measured and the true measure. So if you have two numbers, you see what you're supposed to do. And here now the question is saying find absolute error. The same absolute error which we were saying, if you have a whole number, absolute error 0.5. Then if you have a number with one decimal place, absolute error 0.05. Two decimal place 0.005. Now here it won't work. It doesn't apply here if you have two numbers. The reason why it doesn't apply, meaning you have already upper limit and true measure. So what you do if you have upper limit and true measure and you need absolute error, meaning the number here, the absolute error for you to have upper limit, the absolute error was added already here. So now that's the same thing we need, the one which was added, that's the absolute error. Because for upper limit, we add. We add by what? Absolute error. So we need the same thing which was added. So no wonder here you say for you to get absolute error, you're not supposed to say no, one number, one decimal place. No. Here if you have two numbers, just subtract. So usually just start with the one which is higher minus this. If you want, you can start with the one which is low minus the one which is higher, but understand that the negative will disappear, magnitude. Okay, 26 minus 2.5, you have 0.1. Yes, in case we have people who have issues with numbers, they can't easily subtract direct, this is what you are supposed to do. You just write it like this, in this format. Point, point. Now first number, first number. First number, first number. 6 minus 5, 1. Point will come down. 2 minus 2, 0. 0.1. Done. So you have 2 marks here. Just for this, 2 marks. That's how simple this topic is. It's one of those topics I can easily teach you even when you say you are writing tomorrow. I can just teach you. These are the questions that I can easily concentrate because you can understand. For second theorem, I can't teach you day before. I have to teach you that a week. Not that it's hard, but just for you to understand better. Okay. Next now it's B. Percentage error. Percentage error. So for you to find percentage error, you say PE is equals to relative error times 100%. That's how you find what? Percentage error. Relative error, the same formula I showed you there on the first question, where you say relative error is absolute error over true measure times 100%. Absolute error, you have it absolute error, 0.1. Yeah, you know what's another question? A over true measure. True measure now, understand the English here. The question is saying 2.6. If its true length is 2.5. A true measure. Next, now you remove a point. You can't just divide here direct. Sorry. Okay, there is this. I thought it's relative error. We are calculating percentage error. So percentage error comes with 100 already. So what you do here, it just says 0.1 times 100. 100, it has 2 zeros. So the 2 zeros will push the point to your right 2 times. Then you end up having what? 10, because the point was here. 1, 2, because of the 2 zeros, over 2.5. Percent is still here. Then 2.5 into 10, if you can't divide, again you have a point here, remove it. So now for you to remove, you have one number after a point, meaning you use 10. You use 10, but now you can't just multiply it down. Whatever you do down, that's what you should also do on top. So now you say 10 times 10, 100, over 2.5 times 10, 25. Then now we divide 25 into 100, how many times? 4%. So that's your answer. Whether you are solving a different question, the concept is still the same. It's still the same. Okay, next now it's a bag of potatoes. Different from question 1, 2. Different, so meaning if you just understand this, then you can easily answer a different question from the same. If you can't, then just inbox me a question which you feel, no, this one is different, or this one you didn't mention from this. But I feel question 1, 2, 3 will cover the whole topic here. It has covered the whole topic here. But if you see a question which is different, then just inbox me, then I'll guide you. Question 3. Question 3, we have a bag of potatoes which has a mass of 15.4 plus or minus 0.05 kg. Then find the tolerance. Remember, tolerance, we said tolerance is equals to upper limit minus lower limit. Upper limit we are getting true measure plus upper limit we are adding. So on this question, when there is a plus here, meaning when you add, then you are getting what? Upper limit. So meaning upper limit here, you say upper limit, you just get the same one now, but you just use plus. 15.4 plus 0.05. When you add here, you have 15.45. That's the upper limit. Lower limit, remember, lower limit you subtract. So now that's the minus which you are seeing there, meaning when you subtract, you get the lower limit. So you say 15.4 minus 0.05. So lower limit here now, you just say 15.4 minus 0.05. You have 15.35. So that's your lower limit. Go back now to tolerance. Tolerance, we said the upper limit minus the lower limit. So upper limit now, upper limit is this one. Minus lower limit is this one. So here when you subtract, you end up getting what? 0.1. That's your tolerance. Okay, next now is write down the relative area of the mass as a fraction in its simplest form. So if you check here, relative area, again, which one? Here. So they will just ask you the same things. Okay, then here now you say B. On B now we want to calculate relative area. So you say relative area is equals to absolute area over what? True measure. So absolute area, we said absolute area is the one which was being added and subtracted so that you get lower limit and upper limit. So meaning you have 0.05. Then true measure is the same one here, 15.4. Okay, so now we want to do it, write it in simplest form. You remove a point here, even here. Now you follow the one with more decimal places, 2. So you say times 100 times 100. So 0.05 times 100 you have what? 5. Over 15.4 times 100 you have what? 1540, meaning the point has been moved 2 times to your right. 1, 2 here. Next now look for a number to go into 5 and 15 what? 40. It's similar, it's just like the same one there. So you say here 5 here 1, 5 into 15 3. Then 5 into 4 it can't 0, so the 4 will be here 40 now. Then 5 into 40 of what? 8. So your answer here will be 1/308. Okay, so that's it on this topic.